Welcome to this ACU Mathcast. In this episode, we're going to look at combining counting methods. Specifically, we've looked at permutations and combinations in the last couple of episodes. And permutations and combinations in and of themselves are sometimes not enough to solve certain counting problems. Sometimes you need both, and even more than that in some cases. Counting can get very complicated very quick, as you've no doubt probably discovered. I want to give us a small example to get started with here. Let's suppose that we have 20 total theater students. And we're going to put on a play. The play calls for the following roles. So we're going to need 3 lead roles. We're going to need 2 supporting roles. So we're going to need to cast these. And finally, we're going to need 8 tech positions. Now, these tech positions are things like lighting and costumes, etc. And for the purposes of this example, these positions are interchangeable. In other words, it doesn't matter who I pick when. The order doesn't matter at all. Alright, so let's take a look at this. The question I have to ask myself is, for each of these roles, does it matter the order in which I pick the people? Here you would say that order matters, because it matters who gets what leading role. The same is true for supporting role. The order matters in terms of who I pick to go in what position. However, for the tech positions, because they're interchangeable, here order doesn't matter. Now, because that's the case, there's going to be a mixture of permutations and combinations for this particular problem. So let's look at this a little bit closer, and we'll start with maybe a slot diagram approach here, where we've basically got 3 decisions to make. The first decision is the decision for lead roles. Now, when I go to choose who's going to get the lead role, there's 20 total theater students to pick from, and I need to choose 3 and arrange them in a very specific order. Because of that, this is a permutation problem, so there's going to be P20, 3 ways to do that. The first step is usually always the easiest one. The second step here, I'm looking at my supporting cast, or my supporting roles, and there's going to be 2 of them. Now, because that's the case, I still need to know what order they're going to come in, which means that I'm going to order them, so this is a permutation. The question is, how many people do I have to pick from? It's no longer the case that I have 20 theater students available, because I've already assigned 3 of them roles. So that leaves only 17 students to choose from, and out of that 17, I need to order them 2 at a time. Alright, finally, our last decision that needs to be made is the decision involving the tech positions. In this case, the tech positions, I'm down to only 15 theater students left. I've chosen 3 here and 2 here for a total of 5. Take away 5 from 20, and that leaves you with 15 students left. Out of those 15, I don't care which order I pick them in, because their positions are all interchangeable. They're all going to be working together anyway. So in that case, I've got a combination problem, and I'm going to, out of the 15, choose 8 tech positions to fill. Now, one of the things I want you to notice here is that not all students were used. Not all 20 students were used. You can see that very clearly by adding up the second number in each of the pieces. Here is 3, and 2, and 8, for a total of 13 students chosen. Now, the question is, what do I do with each of these? Well, because it's a slot diagram, I should be multiplying these. This has to be true, and this has to be true, and this has to be true. So it's a multiplication rule problem. I need to multiply each of these together. So these are fairly large numbers. You wouldn't want to do these by hand, so we're going to bring up our calculator here to figure these out. So we'll start by calculating the permutation first. Followed by multiplying the supporting roles. And then last but not least, we'll do the tek positions. So this is what your calculator should look like if you're trying to do this particular example. There's 3 steps involved. I'll go ahead and hit enter and solve. It's a very, very large number. Not surprising. There's 20 students to pick from. There's a lot of different ways I could cast this thing. So let's go ahead and we'll write this number down. All right, let's go ahead and write this number down. All totaled, this number gives us, let's see here, 11972188800. Stick in some commas here. So this is approximately 11.9, almost 12 billion ways to cast this. So 12 billion possible castings. It's a large number, as is often the case for counting problems. So what I wanted you to get out of this episode was that we can have problems where there's a big group to choose from. We don't have to choose everything out of the group. We only chose 13 of the 20 students here. But we did it in such a way that it involved some parts which had order involved and some parts in which the order didn't matter. If that's the case, then you really need to think about where I should be using permutations and where I should be using combinations. Thank you for watching this episode.